This is 1.2, a prereq skill for Algebra 2, equations of lines. It's not really a chapter in a book if we had one, but it's stuff that needs to be talked about. So we've got a line. It passes to the points negative 1, 5, and 4, 7. We're supposed to use point slope form, y minus y1 equals m times x minus x1 to write an equation of this line in slope intercept form, which is y equals mx plus b, and standard form, which is ax plus by equals c, where a is a positive integer. So there's a lot to this problem. Now, the first thing we're going to have to do is we're going to figure out our slope. So you're supposed to remember that the formula for slope, and slope is denoted with lowercase m, is y2 minus y1 over x2 minus x1. And we get those from our ordered pair here, okay? So this will be my x1 and my y1, and this guy right here will be my x2 and my y2. We're just going to plug some stuff in. So setting this up, I would do 7 minus 5 up top, and down low I would do 4 minus a negative 1. And that would give me 2 over what, 5? So my slope is 2/5. Now, point slope form doesn't care which point you pick. It doesn't. Most people, they just pick the first one they see. So I'm going to pick on this pair right here. So setting up point slope formula, I would have y minus y1, which is 5, equals my slope, which I found to be 2/5, times a set of parentheses with an x minus x1, which is a negative 1. And taking away a negative has always been addition, it always will be. So y minus 5 equals 2/5 of x plus 1. We'll use something we call the distributive property. We'll distribute that 2/5 in. 2/5 times x being 2/5 of x, and 2/5 times 1 being 2/5, because anything times 1 is itself. You know, they learn that in like kindergarten kids. All right, next move, counteract subtraction with addition. So, you know, off to the side in your brain, you need to figure out what 5 plus 2/5 is. I am not a decimal person. You don't need to be one either. In order to add two fractions, you have to have a common denominator. 5 could be written as 25/5. Try and get your brain to start working like that. And if you take 2/5 and you take 25/5 and you add them together, you'll get 27/5. So, just by adding to both sides, I have y equals 2/5 of x plus 27/5. And that, boys and girls, is the first part of this, which is y equals mx plus b. So that part's done. The next part is to write this thing in standard form, ax plus by equals c, where a is a positive integer. So I'm moving my train of thought over to this. Ax plus by is c. Now, layout's important. If I move this over here, I will have a negative 2/5 x because I jumped equality, and if I jump equality, I change my sign, plus that y that's there equal to the 27/5, the constant. C is just a number, is all it is. It's a constant. And it's close, but the disclaimer on this is that a is a positive integer. Now, negative 2/5 is neither positive nor is an integer. Integers are your whole numbers. Now, the easy way to fix this is just do opposites. That's really all algebra is, just do opposites. The opposite of division is multiplication. So what I'm going to do is I'm going to 5 this piece. And if I 5 that piece, I have to 5 every single piece. Now, 5 times a negative 2/5, the 5s would cancel. So I'm now sitting at negative 2x plus 5 times y is 5y equal to, think about this, old school 5th grade math, 5 times 27/5, the 5s cancel, 27. And you're close, okay? The only deal is that the thing in front of x is supposed to be positive. So what we'll do is we'll just divide everything by a negative 1, because a negative over a negative is a positive. That'll give me 2x minus 5y is negative 27. And that is your standard STD form of a line. All right, now I'm only going to do about half of these, all right? So I'm going to skip 2. I'm going to jump down to 3. The lines x equals 6, y equals 3, and y equals 1/2 x minus 1 form a geometric shape. Spoiler alert, I'm pretty sure it's a triangle. Graph the lines, and then find the area of this figure. So if you're in my class, you know, the worksheet you got has a grid. But I can't put those grids up on this glass display. That's why they're not here. So I'm going to have to do a pretty nice, decent grid here. So I have x equals 6. That's a vertical line where x is 6. There's my equation for x equals 6, or there's my line, my graph. Y equals 3. It's going to be right here. I missed it a little bit. Close enough, though. It's y equals 3. And the last one is 1/2 x minus 1. So that is in slope-intercept form. It's going to cross the y-axis at -1, and then the slope is to rise 1 and run 2. So I'm going to do lots of dots. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Should put me about right there. Now, it talks about what they make, okay? They make, when they intersect, this little triangle right here. And it is a very little triangle. And because I already know the slope, rise 1, run 2, I can actually go over another 2 units, and that's where those two things will intersect there. They're going to intersect at 8, 3. Okay. The vertical line and that last line, they look like they intersect at 6, 2. And then the vertical and horizontal line, they intersect at 6, 3. But they made this little triangle right there. Now anyways, we're supposed to find that triangle's area. So the area of a triangle, which, you know, every 5th grader is supposed to know, but I've discovered an alarming number of juniors don't know, is 1/2 base times height. So I know this is hard for some kids, but, you know, think about this triangle maybe drawn a little bit different. We're going from 6 to 8 on the x-axis. We have a base length of 2. We're going from 2 to 3 on the y-axis. We have a height of 1. So the area is 1/2 a base of 2 times a height of 1. And half of 2 is 1, and 1 times 1 is 1. So 1 square unit is my area. Not a hard problem. Really not. All right. Moving on. Like I said, I only knew about half of them. Next thing I'm going to do is 5. Now, you know, kids will watch my videos and they won't do the things that I don't do. That's just being lazy. Like, I'm doing half your homework for you. You can try the other half, kids. You can. You just need to figure that out, that you're going to have to try something some point in time. A line, this is number 5, the next one I'm doing. A line passes through -2, 5 and is parallel to x equals 3. What is the equation of this line? A picture is worth 1,000 words, okay? And you should know how to graph x equals 3. Looks like that. Okay. That's the given one. Some of these problems are really easy. Like, this is not a point slope formula. It's not a here's a formula. It's a visualize and attack kind of problem. Now, a line passes through -2, 5. I noticed the other day that a lot of y'all struggle with plotting points, but there's a line that passes through that thing, and it's parallel to that thing, which means that it has to look like this. Now, what's the equation of that line? Well, that's x equals -2. Vertical lines are always written in the form x equals. 5 is really simple. Let's see, 7. A line passes through 2, 3 and is perpendicular to y equals -6. A y equals a number. Oop, didn't leave myself enough room there, did I? It's going to be a horizontal line. Let's make these small. 2, 3, 4, 5, 6. There is y equals negative 6. Now our point is at 2, 3. 1, 2, 1, 2, 3. And we're going to be perpendicular. Remember the T? We're going to be perpendicular. So we would look like this. And that is a straight vertical line. It's going to be in the form x equals, and the x value anywhere on that line is 2. Sorry, you couldn't see that. 2. X equals 2. All right. Moving on to 9. Classify each pair as parallel, perpendicular, or neither. So there's some things that you need to know about being parallel. Parallel lines have same slope. Perpendicular have what we call opposite reciprocal slopes. And neither just means they're different. Like, if you don't know what neither means, ugh. Anywho, I'm not going to do all of these. I'm just going to do one of them and see how it goes. I'm going to glance at it real quick. Which one do I want to do here? Let's do 9. So in order to see slope, what you really need to do is you probably need to convert to y equals mx plus b. It's the easiest way to see slope because whatever's in front of the x when you're in a singular y equals is your slope. And that's the way I've always done it. So let's do that. Let's start on number 9. To convert to y equals mx plus b, the 6x is going to have to move over, and it's going to change from positive to negative. You jump equality, you change your sign. 24 didn't move, so it's still plus 24. And we're going to divide out the negative 12 because we need a singular y equal to, right? And that'll give us y equals negative 1/2 x minus 2. So I can see that the first line has a slope of negative 1/2, okay? Call that M1, slope of line 1. The second line, if we move our 4x over, we'd have twice y equals negative 4x. I made a mistake. A negative over negative is a positive. There we go. Twice y equals negative 4x plus 8. And we'll divide out that 2 this time. And that'll give us y equals negative 2x plus 4. And I can see that the second line has a slope of negative 2. Well, now what's the relationship between these two things? These two things are opposite reciprocals. They are therefore perpendicular. That's the symbolism of perpendicular. Oops, you probably can't see that. It got in the way of the white text. Perpendicular lines, kids. Perpendicular. All right, and the last one I'm going to do in this video is number 12. Write an equation for a line with a slope of negative 1/3 that passes through the point 4, negative 2 in vertex form. Now, this one is like so easy. It is so easy. Vertex form for lines is not something people would probably teach, but, you know, it makes sense to go ahead and introduce it. You know, when we talk about vertex form later on, we learn that H and K are what we call centers or starting points, and lines don't really have a starting point. They don't really have a center because they go on forever and ever. But all you got to do is plug stuff in. Now, when you use vertex form, that A right there could more or less just be an M. It's a lot like point slope form. It really is, except it gives you a point, and you can just work from that point. All right, so we're just going to plug in. We'll have y equals, we have a slope of negative 1/3, that's given in the text, times parentheses x minus h. And what do you get h and k? Well, they are your x's and your y's. So x minus 4, close parentheses, plus k, and k is a negative 2. And that's it. Like, vertex form, point slope form, they're the same formula, they're just rearranged. But vertex form is nice because this is telling me, hey, if I want to graph this thing, and it's not a part of it, but I'm going to go right 4, I'm going to fall 2, and then my slope is going to be to fall 1 and run 3. And that's what the line looks like. That's why vertex form is so easy. And it's a big deal in quadratics and absolute value, in all the other functions. Vertex form is kind of where it's at. Anywho, there's half your homework. You're welcome.